big ideas that you'll be writing down. And so far we've been talking about the product market in the first several units. But now we're going to look at the resource market and look at how many workers should I hire, or how much land do I need, or how much machinery do I need. And so instead of looking at the goods that I'm selling, I'm looking at the inputs that I'm employing. So why I say that this actually might not be that bad is the fact that it's very similar to the product market. So thankfully we can build off the knowledge that we got from last time. So while it is the hardest content probably, I think that if you did well last unit, this won't be too bad. And so number one, like it says, the economic concepts are similar to those for product markets. The words are changed just a little bit, but the idea is still primarily the same. The demand for a factor of production, such as land, labor, or capital, is derived from the demand for the good or service produced from that resource. And of course, I underlined those words there, so I hope you would too. Derived demand. So that value of the laborer that you are hiring, the wage is going to be set on what they produce. If they produce something that's really good and great, well, then their demand for that product, that laborer, is going to be even higher. And so that's derived demand. If you're producing something that a lot of people can produce and it's not all that great, well, then your derived demand is going to be rather low. So derived demand comes from what's being produced by that factor of production, whether it be labor, land, or capital. I usually talk about labor just because I think it's the easiest to relate to. A firm tries to hire additional units of a resource up to the point where the marginal revenue product, MRP, is equal to the marginal resource cost, MRC. Do you remember from last unit something similar to this concept? Well, let me help you jog your memory. MR equals MC. Remember how many times we said that? And well, it works here too. So MRP, the marginal revenue product, is going to be equal to the marginal resource cost. So the revenue that I'm bringing in is not going to be greater than that cost. You wouldn't want that. And you wouldn't want it to be less than that cost because I could do better. You want it to be equal to that cost. Now I put in a note here, unfortunately, that says in some textbooks the marginal revenue product is stated as the value of marginal product of labor, VMPL. I wish I wouldn't have to include this, but some textbooks and even sometimes on the AP exam, they might use this acronym instead of marginal revenue product. They're both the same thing, but stated differently. So unfortunately, we'll just kind of have to remember that both of them are the same. I'll usually talk about marginal revenue product, but in parentheses, I've included VMPL, just in case you see that in the future. All right, here is number 4 and 5 for the big ideas. In hiring labor, a perfectly competitive firm will do best if it hires up to the point where the marginal revenue product equals the wage rate. Wages are the MRC of labor. So the marginal resource cost, it's how much it costs to have that labor or that land or that capital. But again, I'm talking mostly about laborers, so that's the wage rate that we're giving to those workers. So that's the MRC of labor. And of course, I underline that because that is important. So wages are the same thing. If I say MRC or if I say the wage is $10, then you also know that the MRC is $10. A firm will not hire once the marginal resource cost or the wage exceeds the marginal revenue product. Again, as I said on the last slide, that seems kind of obvious. Why would you hire a laborer that's costing you more than the revenue that you're bringing in? You wouldn't do that. And so again, the most efficient spot would be the wages equal the marginal revenue product, or where MRC equals MRP. If you personally want a high wage rate, what do you need to do? Well, there's a couple examples below there. Make something people will pay a lot for. Work for a highly productive firm. Be in relatively short supply. So people talk about getting an education. If you're willing to go on and get your master's or PhD, every time you go to another level, you are being in a shorter supply. Not many people go on to get their doctorate degree or maybe even their master's degree. So if you do that, then you're going to be in short supply. A lot of you guys have talked about being engineers of some sort. And again, engineers are kind of relatively in short supply, especially women engineers. And so if you're able to do that, you're going to offer a great service to society and plus hopefully get a well-paying job. And the final one there is invest in your human capital. Invest in your education, just like you're doing right now. You know, some of the students in class probably have dropped out of watching the lectures and just copy from their friends. But obviously this is important to you and you want to do well on the test. So kudos to you for continuing to watch these lectures, even though sometimes they might get kind of boring with me talking here. So you're investing in your human capital. You're going to do a great job in the future. And when you get a chance when you're older, you'll get opportunities in your job or place of employment to invest in your human capital as well and share that with other people. I get to do that once in a while, whether it's talking about flipping the classroom, such as what I'm doing here, or maybe some other technology things that I've done in the past. And I've gone to sessions to learn about them, and then I also give sessions to people so they can learn more about it. And that's investing in your human capital. If you want to be a value to society, a value to your workplace, hopefully increase your wages, that's what you're going to do too. Here's number 6 and 7 for the 7 big ideas for the resource market. Real wages depend on productivity. And then if you're wondering how can I increase my productivity, it's based on physical capital, so the tools, technology, machinery that you have to use, your human capital, the time you're investing in your education, labor quality, and again, technology that I just mentioned. So these would be all ways to increase your wages as well. Here's an example that I got from your textbook, and it's looking at the production function for George and Martha's farm. Now, in this example, you can see the number of people that they're hiring and their total productivity, and also their marginal productivity. And as we know, the total productivity is going to be increasing up to a certain point when it might actually start decreasing. And again, if you remember from our Greeby's example, that's when you just have too many cooks in the kitchen. You have too many people there that are arguing or getting in each other's way. You can't stay inside the factory. You're standing on top of each other. And so your total productivity may even start to become negative. But what we do know is that because of the law of diminishing marginal returns, the demand curve is going to be downward sloping. So the marginal product of labor, if we start to calculate that, the change from one laborer to the next one, from 2 to 3, from 3 to 4, if we look at the differences there, they're bringing in less and less productivity. All right, here you have a rather big chart, and it's going to take a little bit of time, but if you could please jot this chart down, and you can even pause right here and go ahead and write that information down. All right, perfect. Now you have the units of resource, which again usually tends to be, in the case that I'm talking about, laborers, the total product that those laborers are producing. Then you have the marginal product of labor. Now remember, if you have the total product there, the marginal product is the difference between going from 0 to 1 units, 1 to 2 units. So all I'm doing there is subtracting. And so for that marginal productivity of labor, you really shouldn't have even needed to necessarily copy it down. You could have figured it out for yourself. So 7 minus 0 is 7, 13 minus 7 is 6, 18 minus 13 is 5, and so on. That's your marginal productivity of labor. So marginal is always incremental, looking at the change from one unit to the next unit. Notice I put a dash at the top there, and that really is something that helps me when I'm looking at how many resources should I hire, because marginal is really in between. But if I put the numbers in between, sometimes it's hard to tell. Should I be buying 1 unit of this resource or 3 units of this resource? How many should I buy? So I put that little dash above, and maybe you want to do that too to make it a little clearer. The product price, well, this is for perfect competition. If you remember, the price for a perfect competition is a straight horizontal line, and therefore the price isn't going to change. It's going to be $2 no matter how much of that product I make, because the demand curve is perfectly elastic. The total revenue. The total revenue can be found by the price times the total product. Again, that's a column that you could have probably done on your own. So 2 times 0, 2 times 7 is 14, 2 times 13 is 26, and so on. So it's price times quantity equals my total revenue. Don't forget that. You'll have to be able to do that. Then your marginal revenue product, or the value of the marginal product of labor, can also be found without me even giving it to you. It's just 14 minus 0, 26 minus 14, 36 minus 26, and so on. That's how much revenue is brought in with each additional worker. Now, if you remember, we wanted to hire where the wage, or the MRC, is equal to the MRP. So if I tell you that the wage is going to be $10, how many laborers would you hire? Did you guess 3? Good. I probably didn't give you enough time on that. So check it out. If you look in your marginal revenue product curve, that's 10. You can find $10, go all the way over, and there's 3 is the number of resources that you could hire. That's where your MRP will be equal to MRC. Well, what if I said the wage was $9? Now how many people are you going to hire? Well, wait a minute. $9 isn't even on there. How would I know? Well, you wouldn't hire the 4th worker because they would be only bringing in a marginal revenue product of 8, and so you'd be losing money. So you would bring in, again, 3 workers where your marginal revenue product is 10. So that's the closest to the wage without going under it. So that's the other thing to look for too. These are all things that are going to be in your packet that you can look at, and you'll be filling in the different spots in the graphs and answering questions. And they're all going to look very similar to this one. So it's important that you kind of start getting some of this information. Being able to find the marginal product of labor, being able to find the marginal revenue product, and then identifying how many laborers would you hire are all very important. Again, this is probably one of the harder concepts in this whole thing, as this part right here. Alright, you don't need to copy this one down. I wouldn't mind if you did, but I'm not going to make you do it again. That's a lot of numbers. But this one's looking at, for imperfect competition, look at the number of resources and the total productivity and the marginal product of labor again. So you can see all those things. Those are exactly the same as in the chart that you did on the last slide. But look at the product price. Now it's a downward sloping demand curve. It's not in perfect competition. So that we know that the lower the product, the higher the price is, and then the more product we have, the lower the price is going to be. So you can see at 280 would be 0 units of resources, goes down to then $1.65 for the 7th unit of the resource. And the total revenue then would be price times quantity, and so you can see that there. And then the marginal revenue product is the difference from going from one to the next. Notice here that the marginal revenue product decreases quite rapidly and even goes negative. And that's again because this is imperfect competition and not perfect competition. If you are asked on the test, is this a market for perfect competition or imperfect competition? One of the things you could look at right away is the product price. Is the product price the same? If it is, it's perfect competition. If it changes, then you know it's imperfect competition. Those are some questions that they like to ask sometimes.